Good evening to all. Okay, so a very good evening to you, Tanushri and all. So please make me sure कि आपको screen and I'm audible to. ठीक है, screen is visible and I'm audible. Uh, if it is so, just write this thing in the chat box. Okay, so that we will move on to the lecture. फिर. Good evening, Swati TS. Okay, so on the behalf of Swati TS answer, I'm considering कि सभी को ओके चरण्य थैंक यू सो मच सो सभी को स्क्रीन विजिबल है ओके सो वी आर जस्ट गोइंग टू स्टार्ट अवर लेक्चर सो हियर वी आर with the very beautiful lecture of geometrical optics lecture number 7 ठीक है we have to do so many lectures in ray optics or geometrical optics because it is a very important topic okay for your exam for your like competitive exam and your board examination this thing play a vital role okay so without wasting so much time let's just get started huh? so आप सब अच्छे हैं मैं तो बहुत अच्छा हूँ इवन आई एम मैं तो सबसे अच्छा हूँ आई होप आप भी अच्छे होंगे एंड जस्ट लेटिंग यू नो कि वी आर ऑन अ लेक्चर नंबर 7 ऑफ ज्योमेट्रिकल ऑप्टिक्स ठीक है सो या ज्योमेट्रिकल ऑप्टिक्स आज देर इज नो टिपिकल मिस्टेक ठीक है आज लेक्चर नंबर 7 है तो लेक्चर नंबर 7 ही है ओके सो हियर द फर्स्ट थिंग फर्स्ट what we are going to do is recall as we do in our lectures ठीक है as we often do in this lecture in these lectures then we are going to learn a very beautiful topic is prism ठीक है then we are going to do something about the deviation by the prism because any spherical or any surface that can reflect the light cause the deviation in the light so prism is also such a device which reflect the light okay so it also causing some deviation that we are going to see ठीक then we are going to learn about the relation between the refractive index of the material of the prism and the minimum deviation. Okay, so it is an important formula also. You can just learn the formula because direct question has been asked from this formula. Okay. Then we will see the graph between deviation of prism and angle of incidence. It is a very complicated type of graph. Okay. Although it appears to be simple, but the thing that it convey to us is complex. But you do not have to worry because I am here to make that complex easy one. Got it? So yeah, just start the topic. Just a second. Yeah. Okay. So here we are with the very first slide of recall part. So recall में हमें क्या करना है? We have done the real depth and apparent depth. ठीक है? I'm just revising the formula for you ना. So we have deal with when the object is in a denser medium. ठीक है? Look, for this situation ना, for these types of question in which real and apparent depth has been asked, you have to decide in your mind that which quantity you have to focus. Are you focusing on the observer? Are you focusing on the object? So for the simplification, because we measure the distance, yeah, we measure this depth, apparent depth or real depth for the object, okay, for the object, not for the observer. So I have decided that we will take the situation based on the object. ठीक है कि ऑब्जेक्ट कहां पे है, इट इज गोइंग टू डिसाइड द रियल डेप्थ एंड एपरेंट डेप्थ. ओके, सो फर्स्ट सिचुएशन इज दैट व्हेन ऑब्जेक्ट इज इन ए डेंसर मीडियम. ठीक है, जब ऑब्जेक्ट डेंसर मीडियम में होगा, ऑब्जेक्ट इज इन डेंसर मीडियम. Remember the example that I have told you. Put the coin in a glass of water and you will see that that coin is somehow uplifted, somehow above. It appears somehow above to you. Okay? So, which means there is a decrease in the real depth of that coin, which is given by the formula D is equals to R by mu. And mu is always greater than 1. Okay? I'm writing it here. Mu is always greater than 1. Okay? And what is mu? Mu is the optical friction for light. ठीक है, you never ever going to read this term कि optical friction आपको कहीं पे लिखा मिलेगा ना. This is what I'm telling you because it is a friction for light, because it is the cause for which the speed of light get decreased when it enters in a medium. ठीक है, rather than vacuum or air. Got it? So when object is in a denser medium, then its apparent depth decrease, and how many times? Mu times R by mu. Got it? Where R is the real depth, D is the apparent depth. When object is in a rare medium, rarer, okay? Optically rarer medium, like in air. Got it? So in that medium, oh my God, there is a mistake here, na? This D and D is same. I have recognized it. So we are going to, this is not the formula. D is mu times R. Okay. So this real depth, okay, the apparent depth is going to increase by how many times? Mu times. ठीक है, इसे ऐसी सिचुएशन समझो जैसे कि आप नहा रहे हो गए, you are taking bath in swimming pool ना, and there is some, your friend is standing on like what is say on the plank and it is trying to jump. So you will see, you are inside the swimming pool, you will see, oh my friend is यार ये तो बहुत ऊंचे से कूद रहा है, because the real depth is not appear to you. What will appear? The apparent depth. And when you are in a denser medium, then object is in a rare medium and your friend is object then. So if your friend, हालांकि your friend is jumping from a height of 2 meters only, but it will appear to be, oh, this is he's jumping from 5 meters or 4 meters. He's very brave. It is not a brave kind of thing because it is the optical illusion that you have. Got it? So general formula for this you can remember, it is mu2 by mu1 equals to R by D. What is mu2 here? Mu2 is the medium of object. I have simplified it. Rather than writing it as that mu2 is the medium from where the ray is coming and mu1 is the medium from where ray is going. It just gave the uh, hypothermia to our mind. Na? What is this? From where is ray is coming? From where ray is going? No, you will just remember mu2 is the medium where object is present, because obviously rays are going to travel from object to observer. Okay, so wherever the object you have placed, rays coming from that medium. So mu2 is the medium of object and mu1 is the medium of observer. Simple. Okay, got it? You can derive these right now here. Okay, mu2 by mu1 is equals to what? R by D. If object is in denser medium, which is mu by 1, it is D by R. So D is nothing but R by mu. ठीक है, आ गया ना? And if object is in rare medium, then mu is going to 1. Rare means air मान लिया, ठीक है. We have considered rare medium as air. So mu की value 1, and 4 where the object observer is in a medium of mu r by d. So d is nothing but mu r. Look how simple is this. Okay, I hope you got this. If you have any kind of doubt, you can just write in the chat box. Okay. Now next slide, where the total internal reflection that we have did and the critical angle. So what is total internal reflection? Okay. Total internal reflection is a of property of किसकी property है? It is the property of light, na? Because light is coming, it is moving away from the normal, and if you increase the angle of incidence, it is going back to the medium, means reflection is taking place. Okay, so who is showing this property? So there are two terms, the medium and the light. Got it? So what is total internal reflection? When light comes from a denser medium and going into a rare medium, it moves away from the normal. Okay, this is the formula of refraction. But what if I continuously keep on increasing the angle of incidence? Okay, so this light ray completely, I will have to draw this now. Yeah, so this is light and this is denser medium, this is rare medium. It moves away from the normal. Okay, when you continuously increases this angle, this moves away from this, away from this. So there is a particular angle for which the ray do not enter into the medium. Okay, so that angle for which the ray grazes on the boundary of two medium, or ray travels along the boundary, along the interface of two medium, is called the critical angle. Okay, and if you increase the value beyond the critical angle, the whole ray will diverge in the same medium. If this value theta is greater than theta c, which is critical angle, the complete reflection that you have, and this phenomena is termed as TIR. Okay, total internal reflection. Okay, got it? You can see here the light is coming from water, which is denser than air. So light is moving away, it is bending from this normal. For critical angle, it is not going into the water, it grazes on the boundaries only. Okay, on the interface. Okay, but for the angle which is greater than theta c, the light reflect back, means this medium itself, this boundary behaving as a plane mirror. Okay, got it? So this is the phenomena of total internal reflection. Got it? So yeah, application of TIR. Firstly, the mirage that we have find out. What is a mirage? So in hot summer days, गर्मियों के दिनों में, या फिर if you are in a desert, ठीक है, then what you will see कि जो भी a distant object will appear inverted to you. ठीक है, like a far distance away there is a coconut tree, ठीक है, which is often found in desert na. So there is a coconut tree, and coconut tree is not like that कि वो जमीन से नीचे पैदा होता है, it goes upward, but for you it appears downward because of the phenomena of TIR, and that situation is termed as mirage. And how is this happen? Look, if if this is the tree and you are here, okay, and there is, वो बोलते हैं ना कड़ाके की सर्दी, देन कड़ाके की गर्मी पड़ी हुई है ना, देयर इज अ वेरी हॉट समर डे. ठीक है, सो व्हाट इज हैपनिंग, जो एयर है एडजेसेंट टू द अर्थ which is hot. Hot air means low in density. Low in density. लो डेंसिटी होगी. अपर एयर कोल्ड होगी. कोल्ड एयर ग्रेटर डेंसिटी. ठीक है. सो वी हैव टू मीडियम हियर. वन इज denser, one is rare. Okay, and this is the tree that we have. So rays are coming from denser to rare. ठीक है. It is going like this or any particular angle. So some rays are striking this boundary because this boundary has been created because of the heat absorbed by the air. So this boundary behaves as the interface of these airs, cold and hot air. So for some angle greater than theta c, this ray moves away from the normal. ठीक है. And for a particular angle theta c moves towards the boundary. But if angle theta c is greater than, but if the angle of incidence theta is greater than theta c, then this ray will be reflected. So here you are. So this ray would not appear to you coming from this tall object. It is appear from you to coming from the bottom. So you will see the image of this tree is inverted. Got it? So this is the mirage. Got it? Yeah. Okay. I hope you got this one. Just a second. Yeah. So mirage, you have got it. You can see in the picture also, hot air, cold air, ray appears moving from the downside. Okay. If you will see, they are coming from this direction. Okay. Coming from this direction. Next is the optical fiber. The application of this is the optical fiber. Optical fiber is nothing but the transmission device which transmit the signal from one place to another place without loss of the energy. ठीक है. Without significant loss of the energy. ऐसा नहीं है कि loss होगा ही नहीं. There is a loss, but not the significant one. कि you have entered like provided the energy of 100 joule and by the end you are getting energy of 10 joule. So there is a loss of 90 joule. It is not going to happen. If you have provided 100 joule of energy, in the end you will getting 90 to 95 joule of energy. Okay, got it? So in optical fiber, we have two terms basically. This is the outer layer, the plastic covering for the like the protection of this optical fiber. Okay, and the durability of this. We have two important term here is core and cladding. Core is denser than cladding. Okay, so I can show you like this. This is core and this is clad. Okay, so a ray is coming from outside, bending towards the normal. Clad is less denser. Density of clad is less than density of core. So this ray falls, if it is falls at an angle which is greater than critical angle. So this ray completely reflected again. It will reflected again. So you can see in this also, this ray is going in this direction. And this is the signal. The transfer of signal is possible because of the TIR. Okay. The next application of this is diamond. Yeah, a diamond has a low value of critical angle, which is 24. I have told you in the earlier lecture. So a ray enters at some angle, it goes deflected. It continuously there is a formation of TIR. So that is why it appears as to स्पार्कलिंग ब्रिलियंटली, ठीक है, हीरे जैसी चमक. गॉट इट. सो दिस इज इट. ठीक है. नाउ द प्रिज्म पार्ट दैट वी आर गोइंग टू लर्न अबाउट. व्हाट इज अ प्रिज्म? ठीक है. सबसे पहला क्वेश्चन, फर्स्ट क्वेश्चन अराइजेज इन माइंड, व्हाट इज प्रिज्म? सो प्रिज्म इज नथिंग बट इट इज अ स्ट्रक्चर. ठीक है. Like you take two glass and you join them at particular angle and you fill the material also inside them. Inside is also a glass. Okay. So if two transparent surfaces inclined at some angle, it will form a prism. So prism is a solid, homogeneous, refractive material. Okay. Like in the definition we will say, what is prism? So prism is a solid, homogeneous, refractive medium bounded by two inclined surfaces which are inclined at some angle. ठीक है. I hope this image would clear all the things to you. ठीक है. So you can see these surfaces are inclined at some angle. Okay. And it is a homogeneous medium also, means there is no error inside of it, and transparent also. In general, it will appears as like this. You can focus on this picture. So this, these two are the reflecting surfaces. Refracting surface. ठीक है. Got it? Although prism has many surfaces. ये भी तो surface है. बैक साइड वाली भी surface है. These two are surfaces. But this is not responsible for the phenomena that is taking place here. Why? Because these two surfaces are parallel to each other, not inclined at some angle. So if you enter, if you put a light in this direction, it will behave as a glass slab. It will behave as a glass slab to you. Okay? Got it? So for prism, it is must that from where the incident ray is entering, this surface is somehow inclined with the another surface. Got it? A very interesting thing that I'm going to tell you. Like this is a glass slab. Okay? This is a glass slab we have. If light enters in this way, it goes this way. But what if light enters in this direction, it will goes in about this direction. So these two surfaces are inclined at some angle. So this will also behave as prism. Okay? Got it? It is simple. If you just tilt this, if I just make a tilted diagram of it and I send the ray in this direction, so these surfaces are transparent and also inclined at some angle. So this will appear, this will behave as a prism. Got it? So what is the condition for two surfaces to be prism? That surfaces, yeah, these surfaces are inclined at some angle. Got it? Yeah. Now, if you are clear with this, what is prism and how we can classify any object that it is prism or not, you can just write it in the chat box if you are clear with this. Okay? Now, yeah. So we are going to learn about some definition, important definition of it. The refracting faces, you are pretty much clear what are the refracting faces from where the refraction is taking place. Okay, so these faces are called as the refracting faces. Or refraction kab hoga? When the light enters. So these are the plane surface from which the incident ray and emergent ray will appear. So that surfaces are termed as the refracting surfaces. The next point is refracting angle. It is also termed as the angle of prism. See, these are the two surfaces. So the angle between them on which they are inclined, this angle is termed as the angle, refractive angle या फिर angle of prism. Most commonly, it is called out as the angle of prism. So you will remember this term as a angle of prism. Okay. Now, principal section is the mid section. या सिंपल सी चीज है, मिड सेक्शन से याद रखो, और द सेक्शन बिटवीन दी टू सरफेसेस, टू इंक्लाइंड सरफेसेस. ठीक है, दिस इज द सिंपल डेफिनेशन ऑफ इट. In general, in actual, you will see the prism like this. In your class labs also, I think the prism is available. So you will go through that. So these are the surfaces which are refracting faces. This is the principal section. Okay, and this is the angle of prism. Okay, it will be more clear to you in this diagram. So these surfaces, this one and this one, are refracting surface. This is the angle of prism. Okay, and this whole section, this is termed as the principal section. Got it? I hope you are clear with this. Let's move on to the next slide. Yeah. Now we are going to do some physics and mathematics combined. So it is the part of our study. So we have to do it. So we are going to learn about the deviation by prism. Obviously, because the ray is refracting, okay, and it is emerging out. So whenever the refraction happens, there is a phenomena of deviation because the light deflected from its original path. I have calculated this in the case of, I must say, in the case of glass lab, we have calculated it. Okay, so now we are going to calculate the deviation by the prism. Look, this is the incident ray that is falling on this. Okay. At an angle I. This is the normal. This is a phase. This is the normal to this surface. This angle is 90 degree. Got it? Here is the angle of prism termed as A. Okay. This is the angle of prism, or the another name of this is refractive angle. Got it? If this ray is not going to be refracted, so this will move on to this path. So I have made this path for the clarification of yours. Okay, so this is the original path of incident ray. Original path किसका? Of incident ray. And similarly this is the, like, normal से क्या हुई, bend हुई, because here it is air, here it is also air, and this is a glass of refractive index mu. ठीक है, mu refractive index है. So this is angle I. After refraction it bends towards the normal. This angle is R1. This angle again, it is R2. Again this is a boundary and refraction takes place, so it is moving from denser to rare, so move away from the normal, and this angle is termed as angle of emergent, or this ray is the emergent ray. Emergent ray. Okay, and this is the path of, this is the path of emergent ray. just a second. This is the path of emergent ray. But what if this ray is not going to deflect? So it will move in this direction. Got it? So we have to do some about these angles and all. Okay, we have considered this angle as angle P. Okay, this angle is A, this point is P, this point is Q. Okay, okay. Let me just change the color of the ink. Blue. Or we can take it as red initially. So for the deviation, deviation is this. This is the ray after refraction. This is the ray before refraction. So this angle is delta 1. Okay. Similarly, this is the ray before refraction and this is the ray after refraction. So the angle between them is delta 2. Okay. And what is the total deviation? Look, this ray is going in this direction. Okay. And after all the phenomena taking place inside of the prism, whatever happened, after the second refraction, the ray is emerging out in this direction. So ray is going in this direction and moves after the refraction in this direction. So this is the total value of deviation. Got it? So from the previous knowledge of concept of deviation, we can write it as that delta total we can write, or I am writing it as delta, which is equals to delta 1 plus delta 2. Now what is the value of delta 1? You will see here the angle I is made by this ray to the normal. Okay, so this total angle is I, which is summation of delta 1 and R1. So I is equals to delta 1 plus R1. So we can say that delta 1 is nothing but I minus R1. I minus R1 plus, what about delta 2? Look, this angle from the normal, this ray making an angle R2 from the normal, and after reflection from the normal it is making angle E. This is the original direction, so this angle would be nothing but R2. So what is delta 2? It is E is equals to, E is the summation of R2 plus delta 2. If you have any kind of doubt, you can just write it in the chat box. Okay, you will see it is very simple. So from here you can say that delta 2 is E minus R2. So put the value here. Delta 2 is E minus R2. So delta 2 is E minus R2. So we have I plus E minus R1 plus R2. This is delta, equation number 1. Okay. Now we have to replace this R1 and R2 also. Okay. So if you see, if I note this point as R, okay, on the above side. So in quadrilateral P, P, and this point is, let's say, S. So in quadrilateral PSQR, in quadrilateral PSQR, observe very carefully. P, S, Q, and R. Now, what is the angle P here? Okay, we have considered the angle named as also P. So we will replace this point P and we will say that it is nothing but T. Okay. So in quadrilateral PSQR. So there we have multiple angle. So this angle this angle in this quadrilateral, I will write it here, yeah, like this. Okay. So this is the normal. This is also normal. These lines are normal, na? SP and TS. Observe in the graph. Observe in this diagram. TS and SP is nothing but the normal to this surfaces. So these angle are 90 and 90. Okay. What about this angle? This is A. What about this angle? This is P. Okay. So we can write it as, in quadrilateral, the summation of all the angle will be 360. Okay. So angle A plus angle P plus 90 plus 90 equals to 360. Got it? ठीक है, स्क्रीन सबको विजिबल है ना? If it is not, then please write it in the chat box. Okay, and please respond. So we will see here the angle A plus angle P is nothing but 90 plus 90 is 180. 360 में से 180 कैंसिल करेंगे तो 180. This is equation number 2. Okay. Now in triangle, if you will consider a triangle TSQ, in triangle TSQ, this is T, this is S, and this is Q. This angle is nothing but R1, it is R2, and this is P, angle P. So we can say here that in triangle TQS, angle P plus angle R1 plus angle R2 is nothing but summation of all the angle in a triangle is 180. So from here we can put the value of angle P in equation number 2. So what do we have? We have angle A plus 180 minus R1 minus R2 equals to 180. Okay. So if I just cancel this term, angle A is nothing but R1 plus R2. Okay. So put the value in equation number. This is equation number 3. So in equation number 1, we put the value of equation number 3. So delta is equals to I plus E minus A, and A is the angle of prism. Okay. So these are the two important equations that you will keep in your mind. This is equation number 4. So equation 3 and equation 4 are very important. Okay, just take a note of it, and we will move on to our next topic. If you have any kind of doubt, you can just ask me in the chat box. Okay, and just raise your hand. Okay, you can also raise your hand now if you have any kind of doubt. So Charanya and Pooja, Swati, TS, is this clear to you? Just write this thing in the chat box. Okay, I want to confirm, na? And Devan also is here. Just write it in the chat box if this is clear to you. Okay. Please respond here, guys. Okay. So it will also beneficial for you if you respond. Okay. Okay. Then we will move on to the next topic. It is relation between the refractive index of prism and minimum deviation. So we will consider the value of minimum deviation here. So what is minimum deviation? Okay, we will see, because the general formula for deviation that we have is delta is equals to I plus E minus A. Okay. Now what is the value for minimum deviation? So for minimum deviation, for minimum deviation, there are some condition. And what are those? Angle I, incident angle, is equals to emergent angle. Okay, for minimum deviation. Okay, and if I is equals to E, then R1 is equals to R2 and is equals to R. Okay, got it? This is the two condition for minimum deviation. Okay. Okay. So from here we can say, we in the previous section we have learned that this angle A of prism is nothing but R1 plus R2. So from here we can say R1 and R2 are same and equals to R. So it will become 2R. So R is here nothing but A by 2. Okay. And we are going to use this relation. For delta minimum, I is equals to E. So we put E is equals to I, which becomes I plus I equals to 2I. Okay. Minus A. Put the value of A here also. So delta minimum is 2I minus A. Calculate the value of I. So it will be 2I is equals to delta minimum plus A. I is nothing but delta minimum plus angle of prism divided by 2. So these two relation that we are going to use. Lie, and this is the relation. Okay, and these. Okay. So in prism, this is the prism. Let's say this is the incident ray going on some deflection. This is angle. Again, it is going some angle. So this is angle E. This is angle I. Okay. This is R1. This is R2. And this is the angle of prism A. Okay. So if you apply the Snell's law here, because we have to involve the refractive index of the medium. Okay. So if I apply the Snell's law on first boundary, first reflection, what it will gives us? It will give us that refractive index of the medium multiplied by the sine of angle of incidence, which is outer medium is air. So 1 sine I is equals to mu times sine r. Okay. So put the value of I here. If you put the value of I in this question, what you will get? It is sine delta minimum plus A divided by 2 is equals to mu times, put the value of sine r also. Sine r is nothing but sine r की value क्या है? What is the value of r? It is A by 2. So from here you can say that this mu of prism, mu p will say, mu of prism is equals to sine of delta minimum plus A divided by 2 divided by sine of a by 2. Got it? Okay. You are wondering that how I am able to write this R1 and equals to R2. ठीक है, R1 और R2 कैसे इक्वल होंगे? तो let's see. ठीक है, apply the Snell's law on first boundary. You will get sin I is equals to mu sin R. If you apply the Snell's law on second boundary, in this boundary, what you will have? You will have mu sin R is equals to 1 sin I sin E. ठीक है, because the refracting angle here is E. So you will see that mu sin R, or you will consider firstly it is at R2. ठीक है, so it is sin E, and if you apply the refractive apply the Snell's law on the first boundary, it will gives you sin I equals to mu sin R2 R1. ठीक है, but for minimum deviation I is equals to E, which means sin I is equals to sine of E. ठीक है, so from here you can say that mu sin R1 equals to mu sin R2, and mu got cancelled out, so you will see that R1 is equals to R2. ठीक है, so learn these two formula. This is mu p. ठीक है, this is the important one, and this is also all the boxes that I have made in this concept. You will have to remember that. Okay, I hope this is clear to you. Got it? If you have any kind of doubt, you can ask. Okay. Now the graph between deviation of prism and angle of incidence. Okay. Here we are caught with this graph. Okay. So this graph is made between delta and angle of incidence I. Okay. Okay. So this graph is not like a parabola. Okay. Firstly, you will remember that. First point in this is it is not a parabola because it is tilted from the right hand side. Okay. It is the second point is it is tilted from RHS, right hand side. Okay. Now you will see that here you will have the minimum value of the deviation, delta minimum, for this particular angle of incidence. Let's say I is equals to I, what will we say? Let's say is IC. Okay. If this is the value of I1, you will notice that I1 and I2. Okay. For I1 and I2, you are getting the same deflection. Okay. See, this is also cutting at this point, and this point is similar to this point. Okay. So you will have the two values for I1 and I2. This is also called the principle of reversibility. Okay. The same value of deviation you have. Let's say del 1. So for I1 is also del 1, and for I2 it is also del 1. ठीक है, got it? How is this happen? This is the prism you have. Let's say this is the incident ray you have thrown to it. After getting deviated, it moves in this direction. This is angle E. This is angle I. ठीक है, for which you are having a value of deviation as delta. ठीक है, what if you just reverse the direction? Now you are throwing the light from this direction. If you throw the light from this direction, what will happen? This E becomes I and this I becomes E. Got it? So that is why you have two values of deviation for two different angle of incidence. Got it? Let's say the angle of incidence in the first case is 30 degree and the emergent angle you are getting is let's say 45. Okay, but if you make the angle of incidence from this side as 45 degree, so angle of emergent will become 30 degree. Got it? Okay, so for these two values the deviation that you will have is same, and that is also observed from this graph. For the two different values of angle of incidence, you have same values of deviation. Although if you have noticed one thing, we have write the formula of del minimum, which is nothing but I plus E. Yeah, you can say 2I minus A. Okay, from this relation, or if you try to write the general formula of delta, so it is delta is equals to I plus E minus what? A. ठीक है, so from this relation what you will have, you will see that if you increase the value of A, ठीक है, it will have to decrease in the value, but it is not going to happen. Got it? It is not going to happen because of this complex variation of delta with respect to I. It is practically observed phenomena. Okay, okay. So this is the graph that I want to discuss with you. I hope you are clear with this term. What is this tail minimum and for which angle? Okay, one thing more. You have only one angle for delta minimum. So there is only one angle for which you have the minimum deviation. Okay. Got it? So we will see that we will write it as a pointer. So there is only one value of angle of incidence for which minimum deviation can take place, can occur. Okay, so there is only one unique value of this angle of incidence. Got it? So these are some pointers that I want to remind you. Now next point, the factor on which the angle of deviation depend. Okay. Means this delta minimum. Yeah, this delta depends on which factor. So firstly we will have the refractive index of prism. Okay, just a second, give me 10 seconds. Sorry for keep you waiting. Okay, so refractive index of prism we are talking about, how it is, how this quantity affect the angle of deviation. So if refractive index of prism refractive index of prism increases, then the angle of deviation is also increases. Okay. What about the angle of prism, which is A? If angle of prism increases, okay, if angle of prism increases, the value of delta will also increase. Although we have learned that delta is nothing but I plus E minus A. So from this relation, you can say कि if you increase the value of A, it is going to decrease the value of delta. Okay, but it is the mathematical formula. The what I'm telling you, it is the practical observe. It is experimentally observed. Experimentally observed. Okay. What about the wavelength of light? So if the wavelength of light increases, the delta will be decreases. Okay. Got it? So these are the three relations that you will keep in your mind. If refractive index of if refractive index of prism increases, then delta increase. If angle of prism increases, then delta will also increase. If wavelength of light increases, then delta decreases. Okay, got it? If you have any doubt, you can ask. So here we have a question that an equilateral glass prism is made of material of refractive index 1.5. Find its angle of minimum deviation. Okay. So we are going to solve this question. What is the value given to us? It is an equilateral glass prism. Equilateral glass prism means every angle of the triangle is 60 degree. You all know aware about it, na? So it is 60 degree. What is the refractive index of material? The mu p. Mu p is nothing but so here we have mu p. Mu p we have 1.5. Okay. So we have to find out the minimum deviation. Means del m we have to find out. We are learn the relation of del m with mu p. What is that? Mu p is equals to sine of del minimum plus a divided by 2 divided by sine a by 2. A is 60 degree, which is angle of prism, na? So what is the value of mu p? It is 1.5. It is sine. What is del m plus a? Del m we have to find out, plus 60 degree divided by 2. Sine a by 2 means sine 30, which is 1 by 2. This 1 by 2 goes in this side. So you will have sine del minimum plus 60 divided by 2 is equals to 1.5 times of 1 by 2. So it will gives you 0.75. So del m is nothing but del m plus 60 by 2 is sine inverse 0.75. Okay. So you will see that del m is nothing but 60, sorry, 2 sine inverse 0.75 minus 60. So this is the value of minimum deviation that you have. Okay. So I hope you are clear with this concept of prism, the minimum deviation, the deviation part also, how it is related to the refractive index, and how it is vary with the variation of angle of incidence. So all of the pointers I have discussed with you. Okay. So this is it from my side. Okay. So thank you so much guys for attending the lecture. Okay, I hope you will find the best in it. And okay, keep studying and prepare yourself for the upcoming exams. Okay, and just stay motivated. Thank you so much. Thank you so much for attending the lecture.